Hello, welcome to this tutorial. Today we're going to be coding a max heap. All right, let's create our package, and we're going to call this com.heap package, okay? In the com.heap package, we're going to add a class. We're going to call this class max heap. And we're going to add our public method. Awesome. All right. So let's add our variables for this class. We're not going to make them private. We're going to make them public here. Public. And this here, we're going to create the heap array. It's going to be called heap. And this will be the current size of the heap. So it'll keep track of the size. So let's say the size, or let's say the index of the heap. So let's say if you insert something in 2, the size will be of the index, or the cur size variable will be 3. All right, so we're going to call this one here public int cur size, and then we're going to call this one public int max size. This is the maximum size of the heap. So when we build our heap, we will declare its maximum size. So the max size will be declared on how large the heap can be. And let's create our constructor. Our constructor will be public max heap int. Oops. Let's just call this one here max size. And we're going to use this heap, and we're going to declare the size of the array. Note that the array is not dynamic, it's static. So once you declare the size, you cannot change it. The max size here. Actually, let's make this one here. Let's change this variable here to, array size. Let's just change that here. And the current size when initialized will be 0. You could also think of this as the current size of the index. All right, so let's create our insert function. This is the initializer, or you can say constructor. Here. And let's do insert right now. Size value here. So we're going to insert, and let me just add value. So when you're inserting the value into the array, it's going to insert it into the heap where it is the current size of the array. So it'll keep building and building, like, so let's say if you inserted it in 1, 2, and 3, the current size after the insertion will be 4. So yeah, and then we're going to go current index equals current size now. Oh, let's see where the error is going here. Oh, here it is. Now we have to create a swap function below. So remember, when you it's going to find the appropriate place when you insert for the value. So this is where we do our swap. We go from bottom to top, and we find the appropriate place in the heap for the value here. So that's what we're trying to code out for. And now we're going to code our swap function. We're going to be swapping indexes here. So one will be the temporary, one index will be the temporary value in the here. The heap of 1 will be the temporary values, be temp. And let's do the swap. Oops, mistake here. Now we put our temp value, we swap it with value 2, and our index 2 could say is swap with the temp value. That's going to be placed here. Okay, that's good. Just take a sip of my tea. We go back into insert. We swap it. Two. So if the current index is less than its parent, we get the parent index here. Then we perform the swap operation until this is false, until the statement is false. Then we go here. Now we add 1 to the current size. So if you insert again, let's see, insert at 3, the value will now be, you'll be inserting in 4 the next time you insert a value. All right. So we got that one taken care of. All right, what's the next function we're going to work on? All right, we're going to do our delete function. The way I did delete is a little bit different, and I'll show you. I'll explain in a minute. So all right, so the way I did it is when I delete something in the heap, it will be replace the value I'm deleting will be replaced by the negative infinite value. I'm going to use negative 999 as my negative infinite value. Pretty much is the maximum infinite value. I'm just going to make this one up, and negative 99 is not the negative minimum value in Java, but I'm just going to use it for this sake. And then I'm going to minus 1 to the current size. So it goes back. So when I delete something, the heap, it's still static, but it deletes it goes back. The size gets reduced by 1. Let me just quickly show you here. I'm just going to code it out. This is the replace value. So equals. This is my own way of deleting. Let's make it negative 999. Here. All right. 9. There. Delete value. And then I'm going to pump this one up. And when you delete an item in the heap, you want to swap the root with the last element. So we're going to do that. Swap the last element with the root element. delete the last node. Shrink the heap. Start the position at 0. And when you delete something, we're going to now fix the heap. So when you delete something in the heap, you start from the top to bottom. So the position equals 0. It's actually the other way around. Sorry, you put right here. Wrong way. Okay, and this is our if statement. So we say if the current size, if the left position is greater than the current size and the right position is also greater than the current size, right, oops, T here. And also if the heap's left position is equal to the deleted value, or heap is equal to the right position is equal to the deleted value. So if either left or right side of a tree is equal to the deleted value, then we should just return an empty statement. So here, if the heap is positions, the left position or right position equal to deleted value, return empty statement. Or if it passes the left position or the right position surpasses the current size of the array, then we just return an empty value. Now, this is where it gets good. the left position, the left side of the tree is greater than the right side of the tree, then we do the swap. We swap the left position. So then the left position equals the current position in the heap. And else we'll say the right position. Let's just swap for the right position. Okay. And now we're just going to have another function here to print the heap. So where do you go? Here, here, here. Okay, the bracket is here. We're going to just print heap. Now let's test our heap out. Let's make our maximum heap size here 7. We'll just call it heap. Equals 7. So 7 is now declared in a heap array. And let's insert heap insert, let's say 10. Heap insert. Let's just put the biggest out value first, which will be, let's say 100. Let's make this 70. Paste. Let's make this one here 35. And let's put something at the middle. Let's put 25 around here. Insert 25. And let's print our heap out. All right, let's compile our code. Compile. As you can see, everything is in order. So our tree looks something like this. 10 is the, sorry, 100 is the highest element. And then it's 35 is 2. 25 is 3. 70, and then there's 25 at the bottom. Sorry. 100, 35, and then 70. So let me just quickly draw this out for you. Let me just get a quick draw. Just get something like so. Okay, I can't draw it out. So I'll just quickly write in the comments here. This is how our array looks like, our heap array. Heap array. $100. 35 is 2. 70 is 3. And 25 is 4. I just need to get something to draw this out. I wish I had something like a marker. All right. You get the picture. So let's say I do a delete. Actually, let's make this more interesting, and let's insert the biggest element last, and you will see that 375 is going to now be our root element. Yes. And 375 is our root element. All right, now let's delete something from the array. Let's go here. Let's go to delete. And watch this. Oh, I forgot to print the heap. So you go here. Let's delete it and now print the heap. Save it. And you can see that 375 is deleted. All right, this is it for the tutorial. I'll be putting my code up on GitHub, and you guys have a great day.